Success Stories, a program of the Sorrell College of Business. I'm your host, Alan Mendenhall, Associate Dean of the Sorrell College of Business and Executive Director of the Manuel H. Johnson Center for Political Economy. My guest today is William Howell. He is an entrepreneur and a businessman, and his career has thrived at the intersection of engineering and business. Bill, great to have you here.
Well, thank you very much.
First of all, I want you to explain what you've done in your career, because it is a varied career, and it's sometimes difficult for somebody with no engineering background to explain some of the things you've done, both at W.R. Howell LLC and with Howell, is it Howell Instruments?
Howell Instruments Incorporated, correct.
Yes. Could you explain some of what that career has entailed? Because it works with instruments on planes and all kinds of highly technical devices.
Well, my father started Howell Instruments officially in 1951. My father was a degreed mechanical engineer from the University of Michigan. He was a metallurgist. He had the opportunity of working at Convair in Fort Worth, which is now Lockheed, building the F-16, F-35. They were building the B-36 bomber, and they had jet engines, on which it was a new technology. They didn't really understand it. And so as a tool and die engineer there at the company, they were having difficulty calibrating the temperature indicating system from the thermocouples on the engine all the way up to the indicator in the B-36 bomber. They were spending about 200 man hours to calibrate one engine pod of two engines, 8 thermocouples. And a couple of engineers came up with the idea of putting a soldering iron, heat the thermocouples up to a known desired temperature. And so they came down to the tool and die engineer, which was my father, and asked him to build a prototype and knew what the requirements. So my father designed and built these heater probes that actually just slide over. It's a mini oven that slides over the thermocouples. And then using the traditional instrumentation from the lab, he used the Wheatstone methodology of measuring temperature, and it was very accurate. And they went out and tested it with the prototype and found they could calibrate the engine pods, one engine in like 15 minutes. Then they could do the other engine after it cooled down, do it in 15 minutes. So it was a huge time saver. So my father decided I could do something with this box. I could start a business. And this is after the war, 1950 time frame. So he started his little company, couldn't get an order, finally did get an order, and they took off. And his methodology, or basically his policy, was to listen to the customer, identify a need, take that and develop a prototype as such, build it, put it in the hands of the customer, let him see, does it satisfy that need? If it does, he finds a way to go buy it, you build it, and you support it for the rest of the life. That was his basic philosophy that carried over when I came into the company in the late 1970s. As you said, I was not a degreed engineer. I went to engineering school, but I didn't really understand everything related to engineering design. But I was put through a management program at my father's company. So I learned the company from the bottom all the way up through different departments. And I was put out into the field. And I knew how we built things. I didn't know how to solve things. And so in the field engineering department, you had to listen to the customer. And when you identified that need, you had to come back and communicate it to the engineers properly. To what do you need to build? What do we need to design? And that was the process during my training and development I became very good at, working at. And so in the mid-1980s, I was sent to California. The West Coast was very dynamic. The F-14 fighter aircraft for the Navy was coming about, had a major problem with compressor stalls. And a gentleman at Pax River got with Howell Instruments, and they developed a prototype box to detect when an engine on the F-14 was entering the stall margin and give either a master caution light or give an oral tone in either ear, so that the pilot could now pull the throttle back, because they didn't have an electronic metering system on the jet engines at that time. And the flight characteristics of the F-14, it could get to a point where you disrupted the air coming into the engine, there'd get an imbalance and they had a compressor stall. That happens, the aircraft would go into a flat spin, as you saw in the movie Top Gun. We didn't kill Goose, but we were the ones telling Maverick he had a compressor stall. And I was working out there at that time when they were doing the filming, and I worked in the test cells. My Howell Instruments did the instrumentation in the big test cells for the engines, and in the hush houses, that's where we developed portable test equipment.
Well, you held a number of positions in that company, including eventually CEO.
Correct.
Holding all those different positions helped you not only to learn the science and the technology of these instruments and these devices and all of this technology, but also to learn different facets of the corporation, different facets of the organization, and to help cultivate an organizational culture and learn what other people in the organization are having to deal with, so that when you finally reached the top, you had a familiarity with the functioning of the entire operation.
That is correct. I think most people misunderstand. In a large corporation, it's very difficult for someone to work their way all the way through the massive size of that company. But most really good corporations take personnel that they identify, they'll give them extra education, they'll promote them as they work their way up through the company. In a small environment such as Howell Instruments, it is really a teamwork. And when I say I did this test set or I did that, that's really an incorrect statement. We did it. And it was a team effort. I had to identify, perform my job to explain to this group of people over here who did the hard work, the really innovativeness. And for example, we were going from analog displays to a large display, a touchscreen display. And the technology back there in the 80s was limited. And you were dealing with a very small computer, an XT computer, within the analog A to D conversion of the signals. And so we had to learn to be creative in our software. Well, that took a software guy. You had a double E guy. Then you had a mechanical engineer who was designing the hardware. So it was really a team effort to finish a design that the customer said, yes, this is what I want. And, or can you make it do this? And you had to have the willingness to go back and adjust it and make it work the way the customer wanted to do it. So one of the problems we ran into with the touchscreen display is it had LED displays and an XY grid. So it was firing an LED over here to this receiver and fired LEDs up to this receiver. So you were limited to, once you put your finger on that screen and blocked it, you couldn't put your finger anywhere else on the display. So you were limited. You had to have instruction sets of whatever you wanted the guy to do. He couldn't do a keyboard. He could not do typing. You did a very simple one-finger typing with that display. It was limited in its technology. But one of the problems that came about is the customer would put it in an installation. They'd open up a door and the sunlight at 3 or 4 o'clock in the afternoon came in. It washed out the LEDs. So the display became non-functional during the test at a critical time because the sunlight blocked out the LEDs. So they asked us to look at some new technology to replace that, and we did. We came up with a touch capacitance screen. Same problem. You put your finger on here, then everywhere else you touch that screen, there was no activity. The software couldn't pick it up. So in the 1993-94 timeframe, we spent over a year and a half, and we developed software understanding the capacitance screen to where we could have multi-touch. What you see today with an iPad or with an iPhone, we developed that back in 1993-94 timeframe. So essentially, We had an iPad before anybody else did, but it still had a cable hooked to it. We could have put a battery in it. It would have been larger. We could have put Wi-Fi in there, but the technology was new at the time. There weren't that many Wi-Fi towers. Military did not want to use Wi-Fi on their base. And the internet didn't come about until 1996. So we had technology way ahead of everybody else, but it was designed to satisfy a requirement for that customer and the need. And that same technology is being used today there at Howell with its designs, and they're now carrying it into the cockpit, displays for helicopters, so that make it user-friendly to be able, instead of having somebody push buttons, they can just push the information they want on that touch screen to get the information they want. So the company is very unique, and I was watching a YouTube video from Steve Jobs, and Steve Jobs was talking about how the iPad came about, and he was tired of putting the keyboard in his lap, having cables, having to look up at the screen and see what he's typing. He's not that good of a typist, and he said, guys, I need to be able to see what I'm typing. I want to have a keyboard. I want to have it without cables. Can you guys make me something? It became the iPad. And from the iPad, they used the technology of cutting the glass to fit for their little music recorder. And then they came up with the idea of putting the phone together. So the iPad was actually the very first iPhone. It was a keyboard, very unique design, and had Wi-Fi, had connection to the internet, all of that in 2005. 12 years after where we had developed. But we didn't patent it because we didn't know, we weren't within that industry. We didn't know about apps. Steve Jobs was a genius at what he was doing, but the similarities here is he listened to the customer, or his engineers listened to him as the customer, and we listened to the customer, and we solved very sophisticated problems to make that product satisfy the need that the customer identified. And Steve Jobs was brilliant at it, and he was on a scale billions more than we were, but the similarities are there. The functions, if you're going to go out and start a company, you need to identify what the need is. And that is usually listening to someone that says, I have a need and I'm willing to spend money. So that's why you'd take the effort, the time. Or you can go over and design something, it's really nice, but nobody wants to buy it, and you go broke.
Well, you did not patent those touchscreens, but having moved into the oil realm now and working in oil industry, you have patented some new technologies that have improved drilling operations. And that's
not drilling operations. We improved, lowered the operating cost of a submersible pump.
Okay.
And what the requirement that was coming from people at XTO and Exxon was, we have these ESPs, electrical submersible pumps, and they've got an electric motor down in the bottom of the well, pumping fluid from 9,000 feet, 7,000 feet, 3,000 feet, pushing fluid up. You're fighting gravity and the weight of the fluid in the pipe. One, it's expensive to operate. Two, the reliability is low. Is there any way that you can help us solve those problems? So I had a friend of mine who was doing a ventricular assisted device on the heart, a heart pump. And he was using a different design of the pump. It was small, it was using a brushless DC motor versus an AC motor, which was traditional in the oil and gas arena. So typically, if you were in a 3,000 foot well, you can spend somewhere between 85 kilowatt per hour up to 135 kilowatt per hour to drive that 3,000 foot lift at whatever pressure and pounds per hour that you want to do. So we said, why can't we distribute it and have motors, instead of one down at the bottom trying to fight gravity and trying to solve a 3,000 foot problem, why don't we just solve a 500 foot problem and then stage them every 500 feet? So there's two motors every 1,000 feet. So you have roughly 6, 7 motors in a 3,000 foot. So at somewhere between 5 and 7 kilowatts per motor times 7, that's 35 to 49 kilowatts versus 83 to 135 kilowatts. So it's a big, huge time saver, but there is additional cost. It's more pumps. You have a very rigid real estate. You can't go outside the pipe, but you can go make it as tall as you want, but you got to get your cabling, electrical in there. You're in a harsh environment with acids, all of these different things. And I was not a petroleum engineer. I wasn't a metallurgical engineer in that aspect. And so our philosophy there at this little company that we started was, well, we're engineers. Let's get the books out and let's study it and let's see if this principle can work. And so that is where the patents came from, is that we developed a new delivery system, and using existing technology, instead of pushing fluid up through the coil tubing, we put electrical in the coil tubing. We cut the coil tubing and made connectors, and so we made it umbilical. Now this is very heavy, very difficult, but typically with drill pipe that runs between 30 and 40 feet long sections, for a workover rig to come out on the well would take roughly 3 to 4 days to pull the motor and all the cabling out to service that motor and service all the centrifugal pumps. Whereas we could do it in 4 to 5 hours using a different delivery system, and then pull the system out, get out of the hole, go to the next well. So we improved that technology, and there were several different patents, and we did it as a system rather than trying to take individual patents. And but it's very unique. We came up with a connector that stays above ground, but it allows you to coil up coil tubing and uncoil it, run it through the gooseneck, down through the injector, and the loads that we were carrying with that connector ranged from 98,000 pounds up to we were limited to 120,000 on the test, and the connector worked every time down at Sheldon with the NOV, the manufacturer of the coil tubing. We did very significant tests to prove out it works. But technology within an industry, to get it accepted is sometimes difficult because there's not a willingness to change. That has been, if you're an entrepreneur, as I stated earlier, you're answering what the customers want. There is a need, but sometimes there's just so much resistance, they're not willing to make that change. And you have to be ready for that, because that's the risk.
Well, you went to Grove City College, and while there, you had one very special professor. Who was that?
Oh, he was a wonderful individual, very unique in his own right, and it was Dr. Hans Senholz. He has his PhD in economics from NYU under Ludwig von Mises, and I think he was rough. He may have been a little bit younger, but I think he was the same age as Friedrich von Hayek, who was the Nobel awardee for economics. Very unique individual. The difference between the two students is von Hayek wanted to continue his studies and study economics as a science and write about it. Hans Senholz wanted to take what he had learned and teach other students how to make money and what is right and wrong between the different philosophies of tyranny or freedom. And under tyranny, there are multiple brand names: communism, socialism, fascism. You know, every one of those require tyranny to implement. And he was such a strong advocate because he grew up in an environment of the National Socialist, German Socialistic Workers' Party for the German workers, which was the name Nazi. And most people here in America don't understand that Nazi is National Socialistic Workers of Germany. Very similar to what AOC is talking, American Socialist Party of America for the workers. They never have anything innovative. And that's one thing that Hans Sennholz taught us, is they didn't have any original thoughts. They were copycats. And everything that a socialist does, he degrades and stops innovativeness, competition. It becomes stagnant. And he witnessed this during the 1930s. He became a Luftwaffe pilot. He flew an Me-109 plane, fought on the Russian front, then was transferred to the Africa Corps, went up against the Americans, got shot down, became a prisoner of war. And that is a really interesting, mind-blowing story where he talks that he got on the ship, he wanted to learn English, so he became kind of a gopher for all the officers there. And in the night, they had poker games, and he wanted to learn poker so he could understand English. And when they pulled into Brooklyn, he looked over the ship and he was talking to a couple of the guys, and he said, "Oh, look down here." He said, "Look at all the cars." He said, "Oh, America, they are so industrious, all these cars for the war effort." And the guys looked at him puzzled and said, "What?" He said, "All these cars, look at this is going to the war effort." No, these are the dock workers' cars. What? They're individual cars? They own it? Oh yeah, everybody owns their own car. Oh, the war is lost. The war is lost. This is Hans telling the story. And he ended up milking cows in West Memphis, Arkansas. No guard gate, no towers. And it was just a great story. And his influence on me was not to be a student of economics in the professional sense, but be a student of economics in the applicable sense. Take what I learn and go to the marketplace.
So what advice would you have for students today, college students in particular, about what they should study, what they should be doing to prepare themselves for careers?
I would say the basic element is my recommendation is to look into engineering. You learn the sciences, you become very disciplined. You don't have to be a practicing engineer, but you get a good foundation. And from there, while you're getting your engineering degree, study accounting, understanding how to keep records, how to watch your money. And then after you graduate, focus on going and getting a business degree to understand how to apply those tools towards theories that they're going to apply to you in the MBA. It is essential that you look at college as building a tool set so that you can apply, because you get a degree, you come out, you're 23 years old, 22, 20. Who the heck wants to give you a position of any authority, any management decision when you're raw? But if you go through these different schools and you learn, then you prepare for that day when you have to make decisions or receive an order and implement the order from a direction from somebody. And then if you want to go off on your own, you know what you're doing and why. And then you have to deal with managing with people, which is an essential that college can't teach you. You just have to go do it, and you find out how to either motivate the people or you lose your people. You put good policies in so you keep your people. You have bad policies, they go somewhere else. The whole key is you are constantly learning throughout your life how to do something better every day. You better start at college.
Well, and it sounds as if there is a mix of both the practical and the theoretical. The theoretical can give you the framework, but without the practical, you cannot have a full appreciation and advance to your fullest potential.
Correct. It's like a scale. If you're going to be theoretical, philosophical so much and ignore the practical, you're not going to get anywhere. If you have just the practical and you ignore the theoretical, you're going to have difficulty. You've got to have a balance in the scale. You've got to know the fundamentals, the principles, to apply in the practical world, so you know either one, somebody's cheating you and identify it and not go down that path, or make sure that everything that you're doing is ethical and principled. You have to be a moral individual, because you now have people you're employing. You don't want to hire a crook who's going to steal from you. You want to hire someone that is willing to come. You've got to make them believe in you, trust you, want to work for you. That is the key in entrepreneurship, but you have to have the tools. Otherwise, you're going to wander down the street, pay your money, and everybody's going to go somewhere else.
Well, thank you very much, Bill. It's been great having you on. You heard it here, everyone. Be moral, be ethical, be principled above all else, and that will lead to great things. This has been Success Stories, a program of the Sorrell College of Business. Thank you very much for watching.
Thank you.